In this video, I have explained the behavior of a C++ code by using different types of initializations for structures. First, I will create a structure with name student, struct, space, student, having members of different data types. The first member is name of data type string, string space name, then a member ID of data type int space ID, then a member CGP of data type float space CGPA. Currently, all these data members are uninitialized here. We can provide some default values for the initialization here as well, but that approach was not allowed in previous versions of C++. Now it has been allowed, and we can provide some default values here as well. But currently I have left all these variables as uninitialized. Now inside main, I will create an instance of student space s1. Now this is the variable of my data type student. And let me display the value of the members of this variable s1. Cout name s1 dot name, then id s1 dot id, cout cgpa s1 dot cgpa. This is the definition of the structure. It will not occupy any memory space. The members have also been left uninitialized here. Inside main, when the variable s1 of data type student is created, when this instruction is executed, then memory space is reserved to store the value of s1, and s1 has different data members. So name, then id, and cgpa. These two will be initialized to garbage value because they have been left uninitialized. So whatever value is already present in RAM, that value will be assigned to ID and CGPA. For name, this is a variable of the class string or object of class string. So it automatically initializes it to an empty string. So for the name, the string is empty, and other variables that have been left uninitialized will hold garbage values. So when this line is displayed, then name and nothing will be displayed at the output. For ID, garbage value will be displayed, and for CGPA, some garbage value will be displayed as well. So the output will be name, then ID, some garbage, and CGPA somewhere. So let's display the output. So name, there is nothing written in front of name. ID holds a garbage value, and CGPA also is displaying a garbage value. Now let's try to initialize the value by using the default initialization, default member initialization. So I will initialize it with a value ABC, then ID is initialized to 1, 2, 3, and let's initialize CGPA to 3.56. This is called the default initialization of the members. Now, if you are creating a variable and you have not initialized the variable's members to any values, then the default values will be stored in the memory locations. Now, when S1 is created, then the value stored in S1 will be the default values. Now, when with these values, S1 is created in memory with name ABC, ID 123, and CGPA 3.56. Now, when the program is executed, then these values will be displayed at the output. Let's try to display the values. So name ABC, IDC 123, CGPA 3. Now these values are the default values. When there is no initialization for the members of structure S1, then these values will be assigned. And if you try to initialize any member with any value, then that initialized value will be assigned instead of the default value. Now let's try to initialize the data members of S1 with some values. We have also provided the default values, and here I will initialize the members as well. So the most simple method of initialization is member by member initialization. You use the dot operator to assign values to each field individually. It's explicit, but it can get wordy. In order to initialize the members one by one, you need to use the dot operator or member access operator. S1 dot name equals to Ali. Then S1 dot ID equals to 456. S1 dot CGPA equals to 2.5. Now here I have initialized the members by using the dot operator. One by one, I have initialized all the members. When S1 is created inside memory, then these values, the default values, have been assigned to the members of S1 when this S1 is created inside memory. And when this instruction is executed, ABC will be replaced by Ali. When the next instruction is executed, ID, old value of ID, is replaced by 456. And then when this instruction, third one, is executed, CGPA becomes 2.5. So now Ali has been stored in name, 456 stored in ID, and 2.5 stored in CGPA. Now the program will show these values for all the members. So now let's execute and see the result. Ali ID 456, CGPA 2.5. Let's remove this line and see what happens when this line is removed. When S1 is created in memory, then the default values ABC 1, 2, 3, and 3.56 are assigned to all the members. When S1 dot name is initialized to Ali, then this ABC is overwritten by Ali. When S1.ID is initialized to 456, then 123 is overwritten by 456. And now there is no initialization for the third member. So the third member will remain or will hold the same value of the default initialization value. So it will hold the same default value of 3.56. Now, when the program is executed, then against name, it will display Ali. Against ID, it will display 456. And against CGPA, the default values 3.56 will be displayed because we have not initialized here any value for CGPA. So name Ali 456 and 3.56 CGPA. Now let's remove this line as well. Now when this line is removed, then the program will display name Ali, ID 123 and CGPA 3.56. Name Ali, ID 123, CGPA 3.56. Now if these values are removed from here as well, let's first remove CGPA and let's see the output. Now the program will display Ali for name and 123 for ID, and for CGPA it will display an uninitialized or garbage value. So Ali 123 and uninitialized, a garbage value. Now if 123 is removed from this ID as well, then the program will display garbage value for ID as well. That's how the default initialization works. If you leave any member of the variable uninitialized, then the program will display its default values. And if there is no default value as well, then the program will display some garbage value. Now, the next method of initialization. First, let's remove the default values. Now, the program has no default value, no default initialization. Now let's initialize the members by using brace initialization or by using curly brackets. The values must match the orders of the members defined in the structure definition. Now in order to do brace initialization or initialization by using brackets, first you need to write the name of your structure or data type, then the name of the variable, and then inside curly brackets you need to provide values for all the members in a proper sequence. So first I will give the value for name, then you need to place a comma, then the next value will be initialized to ID, and then comma, and then the third one will be CGPA will be initialized to this value. And after closing curly bracket, you need to place a semicolon. Now, when this program is executed, then name will display Ali, ID will display 123, and CGPA will display 3.4 at the out. Name Ali, ID 123, CGPA 3.4. Let's try to change the sequence. I have written the value of ID after CGPA. So let's try to execute and see what happens. Now 3.4 will be assigned to ID, but since the data type of ID is int, so 3.4 will be truncated and 3 will be stored. So 3.4 is converted into int 3 will be stored, and 123 will be stored for CGPA. So the program will display 123 against CGPA, 3 against ID, and Ali against name. Name Ali, ID 3, CGPA 123. So that's why the sequence of values is important, and you need to provide the values in order of the variables that have been defined in structure. Now, if you left the curly brackets empty, then zeros will be assigned to the values and empty will be assigned to name. So the program will display 00 against ID, and CGPA and name will be assigned an empty string because this is the variable of a class string. For all other variables of different data types, zeros will be assigned. So now let's execute and see the result. Now here program is showing 0 and empty string against name. If you try to provide value for only one variable and skip the values for the rest of the variables, then zeros will be again assigned to all the remaining variables. We have assigned Ali to name and then we have skipped the remaining values, but the program has assigned 0 zeros because we have used these two left and right curly brackets. Now, if you insert another value 3345 after comma, then 345 will be assigned to ID, ID will be assigned to name, and CGPA will be assigned 0 because we have not provided any value. So let's execute and see the result. Ali 345 and CGPA 0. Now, if you want to provide some default values instead of 0, then you may add your default values here, A, B, C. Then for ID 1, 2, 3 and CGPA 4.0. Now let's try to execute the code. Now for this piece of code, Ali will be assigned to name, 345 will be assigned to ID, and instead of 0, 4.0 will be assigned to CGPA because we have not assigned any value here. So the program will not assign a 0. Instead, the default value will be assigned to CGPA. So here the program is displaying Ali, ID 345 and CGPA. Name Ali, ID 345, CGPA 3.4. Another method of initialization is called the designated initialization method or designated initializers. In case of designated initializers, you need to write first the curly brackets, then inside the curly brackets, you need to write dot, then the name of the member, dot name equals the values that is to be assigned to this member, Ali. Then for the next one, you need to place comma and then again the name of the member, dot ID equals to 234. Then again comma and then dot CGPA equals to 3.4. Now by using designated initializers or by using the name of the members for initialization, the code is more clear. Again, the order should be followed. Now the code is clear. We know that we are assigning Ali to name, 234 to ID, and 3.4 to CGPA. Let's execute and see the result. And here small CGPA should be capital because we have defined it as capital. Name Ali, ID 234, CGPA 3.4. Now again, if you remove the line of CGPA from here, then the program will initialize it to default value. So CGPA has been initialized to 4. Now, if the default initialization is removed from the definition, then it will be initialized to 0 because we have skipped the value from here. So CGPA is initialized to 0. Now let's try to change the sequence and see the result. So the program now is displaying ID as 1, 2, 3 and CGPA 3.4. In this case, we can skip a middle value as well. The program will assign 0 to that middle value if default value is removed, and if default value is removed, then 0 will be assigned, and if default value is used, then the default value will be assigned. 1, 2, 3. So let's try to change the sequence. Here I have written ID after CGPA in the initialization sequence. Now let's see what is the program is giving an error now, out of order initializers. are non-standard in C++. So here the program is giving error. So you cannot initialize by writing the values out of sequence. Now the program is displaying all the values. Now if you try to reinitialize any value, let's say I try to reinitialize ID 450, then the program, now when the program is executed, the variable is created by using different values as initialization. The default values are also there. And after the creation of the variable, when this instruction is executed, then the value for ID is replaced by 450. Now, instead of 345 that was initially stored in ID, it has been replaced by 450. Now the program will display ID 450. After that, you may reinitialize the name as well. S1 dot name equals to John, and now I am using the my member initialization here or reinitialization, and these are not in sequence values. By using my member initialization, you may reinitialize any member at any time at any line of code. So now name has been updated to John, ID 450 and CGPA 3.4. Let's try to display these values before the initialization. Now here I will display first these values. So here the program will display Ali against this name, 345 against this ID, and 3.4 against this CGPA. After that, I have reinitialized ID to 450 and name to John. So again, when the values are displayed, then John will be displayed against name, and 450 will be displayed against ID, and CGPA 3.4 will be displayed against CGPA. Let's execute. So name Ali, then ID 345, CGPA 3.4. After that, it has been reinitialized. Now, again, after reinitialization, when the program is displaying values, now ID has been updated to 450 and John has been stored in name. So the program will display name and then John stored in name, 450 stored in ID, and 3.4 stored in CG. So when this structure is stored in memory, then S1 name is assigned Ali, then ID 345, CGPA 3.4. These are the memory contents when this structure is created. And when this line is executed, then ID is replaced by 450, and name, when this line is executed, then Ali is replaced by John. So when the values are displayed again, then the program will display John against name, 450 against ID, and 3.4 against CGP. Another method of initialization for variables in a structure is by using constructors. Most of the time, the constructors are used with classes and objects. So I will explain how constructors works by explaining the classes and objects first.